Hi, today in this video we will talk about covariance, that what exactly is a covariance and how to find covariance. So let's start. First of all, let there be two quantitative variables x and y. So when we are saying quantitative variables, we mean that this x can be basically this x is the observations of the x is in terms of numbers, and similarly for y also the observations for y variable y is also in terms of numbers. So those are the quantitative variables. Let the observations for x be represented by x1, x2 till xn, and the observations for y be represented by y1, y2 till yn, right? So now let us consider a set of n observations x1, y1, x2, y2. These are the set of observations, right? x3, y3, right? On these two quantitative variables x and y, these are the sets of n observations. Or first observation is x1, y1, second is x2, y2, third is x3, y3 till xn, yn, right? So if we have this, then covariance between x and y, which is also denoted by covariance xy, is equal to x1 minus x bar into y1 minus y bar plus x2 minus x bar into y2 minus y bar plus till xn minus x bar into yn minus y bar, right? So we are simply subtracting x bar, that is the mean, from the observation x1, then similarly subtracting y bar from the observation y1, multiplying it and summing it similarly for all the observations upon n, where what is x bar? Summation x upon n, and y bar is equal to summation y upon n, right? So we are saying covariance is simply the sum of x1 minus x sum of observations such that x1 minus x bar into y1 minus y bar. So basically we are just summing it over all the n number of observations, right? So this we can also write like this. This term can be written as covariance of x, y is equal to, can we say like over here, since we are summing it up for all the observations, this is simply summation x minus x bar into y minus y bar upon n, and we are summing it from I1 to n since it's for n observations. So this can also be written as summation xy upon n, where small x is equal to x minus x bar and small y is equal to y minus y bar. So this is the covariance, right? Later on in different videos we'll talk about that where exactly is covariance used, but this is the basic formula for a covariance. So let this be represented by 1. When I'm saying 1, I'm just trying to denote it by 1. Now I'm saying we can also find covariance using another formula, that is summation xy, capital Xy upon n minus summation x by n into summation y by n, or we can also write it as summation xy upon n minus, since we know summation x upon n is mean, from here also we can see, minus x bar y bar. So I am saying that this formula number 2, is same as formula number 1, right? So I am saying if we find covariance using either this first formula or the second formula, both will give us the similar answer, or the same exact same answer. Now why is it so? So see, let me just derive and show you how the equation 1 and the equation 2 or the formula 1 and formula 2 are same. Let's see how. Let's just write down formula 1, right? So what is this formula 1? It says covariance of xy is equal to summation x minus x bar into y minus y bar upon n. And the summation is from I to n. I is equal to 1 to n, right? So over here, see this portion. Let me just mark it up again. So basically, this portion, I'm trying to take this part and prove that this is same as this part. So I've taken this first part. Okay, so now let's just expand it up. So can we say this is summation? I'm just simply multiplying the inner parts. Xy minus x bar y, that is xy, then multiplying x bar and y, then multiplying this x with y bar, so it becomes minus x y bar plus x bar y bar upon n. Now we know that this x bar is a constant and similarly y bar is also a constant. So this becomes summation xy upon n, right? Minus, now we need to sum it up. So x bar is a constant now that we are multiplying, so we can take it outside. So x bar into summation y upon n, right? Minus, again y bar is a constant. Constant means a number, whatever the number turns or whatever the mean of y turns out. So this is y bar into summation x upon n plus, now x bar and y bar is altogether a constant because x bar is also constant, y bar is also constant. So x bar into y bar is again a constant. So we are summing this constant n times. So this becomes n into x bar y bar upon n. This n is the denominator from here, right? So now this becomes summation xy upon n, right? Minus x bar. Now what is summation y upon n? This is nothing other than mean of y, x bar y bar minus y bar. Summation x upon n is again x bar plus this and this gets cancelled. So this becomes x bar y bar. Now from here, can we say this is same as this? So this becomes summation xy upon n minus x bar y bar, right? Or summation xy upon n minus, just from here, this is summation x upon n into summation y upon n. So can we say the two formulas are same? This part is same as this part, right? So because we have derived 1 from 2, so all we can say is no matter how we calculate it, we will always get the same answer. Now we will discuss one another example where we see that both the equations are giving us same answer and how to solve using either of the two equations. Also, we'll talk about that when to use which exactly which formula, like which formula will be easier to use in which condition, right? But that we'll do at the end of the video. But let's first just talk about how to solve the questions using these formulas. Now the question is, calculate the covariance between x and y for the following data. Like when x is 12, y is 14. When x is 9, y is 8. So let this be. So this is basically x1, this is y1, this is x2, this is y2. And we have 1, 2, 3, 4, 5, 6, 7. We have 7 observations. Right? So it's quite clear that n is equal to 7. Right? So now we have two formulas to solve these. Okay? So first is, we all know, that is covariance of xy is equal to summation of x minus x bar y minus y bar upon n, or we can say it's summation of small xy upon n. And another formula is summation xy upon n minus x bar y bar, or summation xy upon n minus summation x upon n into summation y upon n. See, the two formulas we have noted is already over here, right? I've just simply copied it up from here or here. Okay. So now what all figure do we need in order to find it? So we need x minus x bar, right? So let's just write down what all stuff do we need. We need x minus x bar, y minus y bar, right? So for this, first of all, we need is x bar and y bar. And then we need x minus x bar, y minus y bar, right? So let's start writing down. First of all, let's find x bar, y bar. So this is x and this is y. So to find x bar and y bar, we all know that x bar is equal to summation x upon n. So from here, if we find out summation x, so it is simply the sum of 12 plus 9 plus 8 plus 10 plus 11 plus 13 plus 7. This is equal to 70, right? And similarly, we'll sum up y. So when we'll sum it up, 14 plus 8 plus 6 plus 9 plus 11 plus 12 plus 3, and this will be equal to 63, right? Okay, so x bar is 70 upon 7, which is equal to 10. Y bar is also equal to summation y upon n, which is equal to 63 upon 7, which is equal to 9. Now we have x bar and y bar. Okay. Then what do we need? We need x minus x bar. So let's just write it down. We need x minus x bar. Right? What else do we need? We need y minus y bar. We need y minus y bar, which is also equal to small x. This is also equal to small y. Then we need is summation of x minus x bar into y minus y bar, or summation of multiplication of xy. So it is xy. That is, if this is our column number 1, this is 2, this is 3, this is 4. So what is this? So we can say 5 is simply equal to column number 3 into column number 4. Right? So this is all we need for the first formula. Okay. What else do we need for the second formula? So we need summation xy. Capital X into capital Y. Have we written it down here? No. So let's just write it down. xy. And xy is nothing other than 1 into 2. Right? Okay. And minus x bar y bar, that we have already computed. So all we need is this summation xy upon n. So for that we need xy over. So now let's just simply find out these values, and then we'll put out these values in the equations and we'll get the answer. Okay. So I'm just using both the methods simultaneously, but otherwise you have to solve only using one method. Either you can choose this or you can choose this. Okay. Okay. So x minus x bar. So that was 12 minus 10, which is 2. 9 minus 2, 9 minus 10 is minus 1. 8 minus 10 minus 2. 10 minus 10 0. 11 minus 10 1. 13 minus 10 is 3. 7 minus 10 is minus 3. Then is y minus y bar. So it is 14 minus 9. That is 5. 8 minus 9 minus 1. 6 minus 9 minus 3. 9 minus 9 is 0. 11 minus 9 is 2. 12 minus 9 is 3. And 3 minus 9 is minus 6. Right? So next we need is 3 into 4. Right? So we need is x into y. 2 5s are 10. Minus 1 into minus 1 becomes 1. Minus 2 into minus 3 becomes 6. 0 into 0, 0. 1 into 2, 2. 3 into 3, 9. Minus 3 into minus 6 becomes 18. Right? Next we need is x into y. That is 1 multiplied by this. So 12 into 14 is 168. 9 8s are 72. 8 6 are 48. 10 into 9 is 90. 11 into 11 is 121. 13 into 12 is 156. 7 into 3 is 21. Right? Okay, we have all of this. We have computed. So now again, I'm just writing out the formulas over here. That is, first formula is covariance of xy is equal to. So first formula is the summation small xy upon n, and second formula all we know is summation xy upon n minus x bar into y bar. Right? So now let's just take out the figures from the question. So summation xy upon n. For that we need this sum of column number 15. Right? So all we need is we need to add it up. 10 plus 1, 11, 11 plus 6, 17, 18, 19, 28 plus 18, 46. So this is our summation xy. So now, and n we know is already 7. So putting it over here, this is 46 upon 7, which is 6.57, right? Similarly for this, summation of capital XY, we need to add this up. So 168 plus 72 plus 48 plus 90 plus 121 plus 156 plus 21. This gives us 676, right? So this is our summation XY. So let's just write it down. Summation XY is 676 upon n, that is 7, minus x bar into y bar. What is x bar? It's 10 into 9. Right? So this becomes 96.57 minus 10 into 9 is 90. So this becomes 6 into 57. So here we have solved the question using the two formulas simultaneously, but in exam you only need to solve it using one formula. You can either make table 3 and 4, or you can create 3, 4 and 5, or you can create table number or the column number 6. It's optional to you. Now, see, we all know it's so if we simply make this table number 6, it's quite easy for us to solve the question, right? Because we just need to make a single column out of it, right? But the question stands here, when to use which formula? Because from calculations point of view, we can say making column number 3, 4 and 5 is easier. From calculations point of view, we can also use this, or we can also use this. So how to decide? So see, it all depends. Sometimes what happened is capital X and capital Y, the figures over here, like these observations, are quite large in number. As the numbers are quite large, let's suppose 676 is the figure, let's suppose 892 is the first observation for X. So it becomes quite difficult to multiply X and Y if the observation values are quite high, right? If the value of this observation is observation 1 is quite high, similarly for 2, similarly for 3, then it's quite difficult to multiply the two figures X and Y, capital X and Y, right? So in that case, we use our very first formula where we don't need to multiply them up, right? One is this. Now, when to use this formula? Covariance of xy is equal to summation xy upon n minus x bar into y bar. We need to use this formula majorly when we know that x bar and y bar are in decimals. See, over here, if this figure of x bar and y bar is in decimals, then obviously each figure, these will also turn out to be in decimals now, right? Am I right? These will also turn out to be in decimals, so it will be very difficult to then multiply it for the column 5. So in that case, we use this second formula where we don't have to subtract the mean. But when the figures or the observational values are very, very high, in that case, we simply use the first formula. So it all depends upon the question for us to decide which formula to use when, right? So in the later video, we'll talk about covariance with change in origin and change in scale. That is it independent or not? So in our next video, we'll talk about that. I hope you liked this video. Do subscribe this channel for more videos. Thank you.